Video is mainly going to focus on the examples, the advanced organic nomenclature examples. So I'm going to whip through the notes portion in just a few minutes because you guys can read through these and see all of the different little picky rules that are involved. The main thing that we started with the aromatic hydrocarbons, you've seen these before. Benzene, you should know that benzene has 6 carbons, alternating double and single bonds. Don't worry so much about toluene, xylenes, and naphthalene, but just realize that those are aromatic hydrocarbons. And then alcohols, this is a new one for us. We see them as having a hydroxyl group at the end, or somewhere on the chain of carbon. So you have an OH, and you change the ending to OL, so you get rid of the E ending, and you change the ending to OL. So you can read through the rules. For example, you have 5 carbons, so it becomes a pentanol. Well, you have a hydroxyl group that's on your second carbon. And we see that the hydroxyl group takes precedence over any other alkyl group in determining how you number that chain. You can also have alkyl halides. You saw this last unit. We just kind of stuck those in and you guys figured them out. That we can have any of those halogens and we can just tack them on in place of just like a substituent group. So you count your chain of carbons and you just tack on a fluoro, chloro, bromo, or iodo and you number it. Well, if you have an alkyl group or you have an alkyl halide, both of those have equal rank is what we end up seeing. So as far as numbering goes, you just want to make the lowest number possible. It doesn't matter which one it is, if it's halogen or an alkyl group. However, when you have a hydroxyl group, again, that's just your OH, it does take precedence over the numbering system, so it's always going to be the lowest number. Then we get into our new ones. Ethers are the first of the functional groups that we're going to look at. And the way you can recognize these is that they have an oxygen that's in the middle of your chain of carbons. So maybe you want to think about this as being the ether bunny. And here you have your chain of carbons on each side of your oxygen. And I'm kind of giving you this goofy little example because you're going to get confused. After a while, you're going to have so many to remember. If you have something simple like this to think about, it might help. So it's the ether bunny. You've got your oxygen in the middle with your carbon chains on each side of that. The way you name these is you're going to look at each of these. Here we have an ethyl. Here we have another ethyl. So since it's symmetrical, you're going to say it's a diethyl ether. Here on this side, you've got a methyl. On this side, you've got an ethyl. Well, what you need to do is alphabetize them, and you get an ethyl, methyl, ether in that example. Then we get to aldehydes. Aldehydes are characterized by having a double bonded oxygen on a carbon and then also a hydrogen there. And when you see this, it's always going to be on what's considered a terminal carbon, which is kind of a misnomer because it's really going to be your first carbon. But when written out, typically it's on the right-hand side. I think that's why they call it the terminal carbon, but it's on your first carbon. The way you name these is you change the ending, you get rid of that E, and you change it to an al ending, AL. So make sure you're really clear about whether that's an A or an O so that it doesn't look like a hydroxyl group. So here we have some examples that you can look through. Another one we have is ketones. Again, you have your double bonded oxygen, but instead of being on the terminal carbon, it is just somewhere within that chain. So the way you name these is one is at the end. You've got your double bonded oxygen, and you would just name this as, in this first example, you've got 1, 2, 3, 4, 5, 6 carbons. So you're going to have a hexanone. Then you have to name where that double bond comes off of, so it comes off the third carbon. You always want to do the lowest, so a 3-hexanone would be that example. You've got this on your notes. You can go ahead and cross this off. This is just another naming system, and we will not use that or hold you guys responsible for that. Okay, then we get to carboxylic acids. Here, again, we have a double bonded oxygen, but along with that, and I don't have this written here, along with that, you've got another oxygen bonded to that carbon. So you've got 2 oxygens bonded to the carbon, and it's going to be at the tail end of your chain. So in other words, it's on a terminal carbon again. But remember, in your numbering, that becomes your first carbon. And here you can see the way you would say that if you've got 1, 2, 3, 4, 5, 6 carbons in this example. It's a hexanoic acid. That's this portion. Well, this carbon right here has to be your number 1. You've also got a methyl group coming off of carbon number 4. So 4-methyl hexanoic acid. This example, actually mine's a typo here. It's hard to see. Look really closely at your notes, but right there between carbons 4 and 5, you've got a double bonded carbon. So double bonded carbons. So that would be, instead of a hexanoic acid, it's hexenoic acid. So you have a hexene. And in that case, you have it coming off of carbon number 4, so hexenoic acid. And here we have our last one, are esters. And really these come from both. When acids and alcohols are combined, you get esters. What you're going to notice when you're looking at the chain is you're going to see a double bonded oxygen to a carbon, and you're also going to see another oxygen within that chain. So you've got some verbiage here about how you can go through figuring this out, but another really easy way to think about this is if you follow towards the oxygen. So from my double bond, I went to the right-hand side towards this oxygen, so that's going to be the dividing line. I'm going to mention this side first, because that's which side I start with, and then this side second. It's not because this is on the right-hand side and this is on the left. I'm going towards my oxygen to name that first. So you're going to have an O8 ending, and then you'll just name those alkyl groups on each side. So in our first example, we've got 2 carbons, so that's going to be an ethyl, and then we've got 2 carbons over here. Don't forget about this carbon. This is a typo here. So we have an ethyl ethanoate. And this one, I'm going this direction again. So we've got a methyl propanoate. So now we get to our examples. And I'm going to try, really what I want you guys to do as you're going through this, I'm going to try and do it quickly. Stop it if you need to. But the main thing, one of the big things you need to be able to do is make sure you can identify which functional group you're looking at. So this first example, I see this hydroxyl here, so I know that I'm looking at an alcohol. So the way I'm going to number this, I've got 6 carbons across here, so it's a hexanol. And then I see that my hydroxyl group is coming off of carbon number 2, so it's a 2-hexanol. Over here, there's the ether bunny, so we've got an ether, and on each side of that we've got methyls, so you have a dimethyl ether. Coming over to this one, I see that I've got that hydroxyl group, so that's going to make it alcohol. And you've got 2 carbons, so all that becomes is an ethanol. Do not write a 1 there because there's no other possibility. It's got to be a 1, so it's just an ethanol. In this example, we have an aromatic hydrocarbon. So that's got to be a benzene. That's really all we're holding you guys responsible for. It's a benzene because you've got those 6 carbons with alternating double and single bonds. And on top of that, you've got bromines that are attached to numbers 1 and 4. So 1, 4 dash dibromobenzene. Okay, next one. Nothing too unusual about this. You've just got that iodine that's attached there, so we're just going to call that an alkyl halide. He's kind of low on the totem pole, so if you had other things, other functional groups, you would label those. But this is all we've got. So we've got 1, 2, 3, 4. So it's going to be a 2-iodobutane. Over here, double bonded oxygen on a terminal carbon, so that's going to be an aldehyde. And 1, 2, 3, 4, it's going to be a butanal. Make sure that looks like an A when we're trying to grade that. Okay, next one, you see a hydroxyl ending again, so that means that it's got to be an alcohol. 1, 2, 3, 4, 5, 6. So that's going to be a hexanol. And on top of that, we've got this ethyl, it's an ethyl group coming off of carbon number 1, 2, 3, 4. But there's another really important thing we need to do. We need to label where this hydroxyl group is. So we have a 1-hexanol and then a 4-methyl on top of that. So it becomes 4-methyl 1-hexanol. And last one on this slide is going to be this double bonded oxygen in the middle of our chain. So that's going to be a ketone. And there are 6 carbons, so that becomes a hexanone. Well, where is that double bonded carbon or oxygen coming off of? Carbon number 3, so it's a 3-hexanone. On top of that, we've also got a methyl coming off of carbon number 5. So 5-methyl, 3-hexanone. Okay, next one, again, we have a double bonded oxygen that is coming off of a carbon, and it's not terminal, so it's got to be a ketone. And we see that we've got 5 carbons, so that's going to be a pentanone. And our double bonded oxygen is coming off of carbon number 2. Okay, over here, you've got your double bonded oxygen, but on top of that, you've got this oxygen right here in the middle of the chain. So that's going to have to be an ester. And the way we're going to number this is we're going to go ahead and we're going to start on the side closest to the oxygen, the way we went from the oxygen. So you've got 1, 2, 3, which gives you a propyl. And then when we count the other side, 1, 2, 3, don't forget this double bonded carbon as well. So propyl propanoate. Okay, same sort of situation in this other one, except we're going in the other direction. There's the dividing line. I want to label this guy first, which is methyl, and then 1, 2, 3, 4, 5, so it's going to be a methyl pentanoate. Okay, and then last one on this slide, we've got double bonded oxygen and another oxygen in there, but it looks like it's in a terminal group right there. So we have a total of 7 of those. So it's going to be, actually I should label this first. I should have labeled this one. This was an ester. So since you have your double bonded oxygen and another oxygen that's going to be terminal, that's got to be a carboxylic acid. And this one, there's 7 carbons, so it's heptanoic acid. There's nothing else coming off of it. Okay, flip your paper. And the next one we have is, we look at this and there's 6 carbons that have alternating double and single bonds. This is just another way of showing that. That's if you look at your notes again. So this has got to be an aromatic hydrocarbon. And it's going to be a benzene. Well, we've also got a methyl and an ethyl. We have to alphabetize. One of those needs to be a 1, one needs to be a 2. Since we're going to alphabetize and put our ethyl first before our methyl, may as well make that a number 1. So it's going to be a 1-ethyl dash 2-methyl benzene. Here we have double bonded oxygen, and it's a terminal carbon, so it looks like it's got to be an aldehyde. And you've got 4 carbons, so it's going to be a butanal. Oh, we've got this guy, he almost blended in, so you've got a methyl coming off of number 3, 3-methyl butanal. Okay, next example. Got that oxygen hiding right in there, so that's what we have to think about. We're going to do this side first, which is methyl ethanoate. Okay, double bonded oxygen looks like a key. Here we've got it right there in the middle of our chain, so that's going to be a ketone. And 1, 2, 3, 4, 5, 6. So it's going to be a hexanone with, if I count starting with my carbon on the left side, I can get it to be a 3-hexanone. I don't want to start at the right side. That would give me a 4-hexanone, which would be incorrect. Okay, then we have this guy, which shows me that it's an alcohol. And we've got, looks like 6 carbons. So it's going to be a hexanol. And that alcohol is coming off of carbon number 3. Well, on top of that, we've also got some methyl groups. You have to keep counting the same direction. I use this as my carbon number 1, so that has to stay carbon number 1. So we end up getting a 4,4 dash dimethyl dash 3 dash hexanol. Okay, over here we get this going, which says it's got to be an ester. Here's my dividing line. I'm going to start with this. There's 3 carbons, so that's going to be a propyl. And then 4 carbons, butanoate. Okay, let's go down here. Same sort of thing. I'm going to do this where I've got this as my dividing oxygen. So I've got 2 carbons, which gives me an ethyl. And then 2 carbons, ethanoate, because this was an ester as well. Okay, I'm going to do this easy one real quick, and then we'll look at the harder one. So my easy one, hydroxyl group, which means it's got to be an alcohol. And that's the easiest, simplest alcohol of all. It is just a methanol. No numbers go with it. Now with this one, this can be a little tricky because what we're looking at is a condensed structural formula, and sometimes you can kind of skip over some things and assume this is something else. This is not an alcohol. You've got an HO at the end, but what you're not seeing is any double bonds or anything like that. So let's draw it out in more of a structural formula where we've got 4 carbons, here's 3 hydrogens, here's 2 hydrogens, here are 2 hydrogens, and then on the end I've got an H and an O. The only way to make that carbon happy is if one of those is double bonded. That's that double bonded oxygen, and then you've got a hydrogen there. That signifies that it's got to be an aldehyde. So in this case, all it's going to be is 4 carbons, so it's going to be a butanal. So those condensed structural formulas can sometimes be a little tricky. Just watch out for those. Here is another example where we've got that condensed structural formula, but hopefully you can look at that and realize that that's going to be a carboxylic acid. And we've got 4 carbons, so that's going to be just butanoic acid. Over here, you've got just a double bonded oxygen, nothing else going on, and it's in the middle, so it's got to be a ketone. And there are 3 carbons, so that's going to be a propanone. And to be honest, a propanone is really all you need. You don't even need that 2 because it's not possible to have it. If it were on one of the other carbons, it would no longer be a ketone. It would be an aldehyde. So just a propanone is all we need. Okay, in this example, we've got a hydroxyl group. Remember, we said in numbering, this takes precedence over any of your alkyl halides or alkyl groups. So let's let it take precedence over the naming also. I think it's more important that it's an alcohol. So we will call this an alcohol, and when we name it, there are 3 carbons, so it becomes a propanol, and our hydroxyl group is coming off of carbon number 1. We've also got a chlorine that's coming off of carbon number 2, so it becomes a 2-chloroethane. 1-propanol. Okay, now we've got another situation where we have COOH at the end, so it's terminal. It's got to be a carboxylic acid. And in this case, we count our carbons, and there are 5 of them, so it has to be a pentanoic acid. And then we've also got a methyl group coming off of carbon number 1, 2, 3, 4. So 4-methyl pentanoic acid. And last one. In this case, this is that tricky one again, where we've got this ending, which is going to actually be an aldehyde. And when you name this 1, 2, 3, 4, 5, you've got a pentanal. And on top of that, you've got a methyl that's coming off of carbon number 2, so it's 2-methyl pentanal. Ta-da, you guys are chemistry geniuses. You can do all sorts of organic nomenclature now. Congratulations.